A really cool application of the rational root theorem is proving the irrationality of numbers. So you're probably pretty familiar with rational numbers, numbers that you can write as fractions. You're probably less familiar with irrational numbers like pi or, oh, that's obviously rational, 6/7. I wrote it as a fraction. But things that can't be written as fractions. So like infinitely repeating numbers. So when I say that square root of 6 is an irrational number, this is me saying that square root of 6 can never be written as a fraction. No matter what p and q are, it can never be written as an integer divided by another integer. And let's show this. So if I think about the polynomial x squared minus 6, this is a polynomial with integer coefficients, right? The first coefficient is 1. The second coefficient is minus 6. So it's a polynomial with integer coefficients. So therefore, by the rational root theorem, the only possible rational roots are at where? P over Q, where P divides the 6 and Q divides 1. So the options for P are plus or minus 1, plus or minus 6, plus or minus 2, plus or minus 3. And the options for Q are just plus or minus 1. So my options are plus or minus 1, plus or minus 6, plus or minus 2, plus or minus 3. These are the only possible rational roots. Now, if I take every single one of these and I plug them into that polynomial, it's an even polynomial, so you can really just look at positive 1, positive 6, positive 2, and positive 3. But when I do that, right, if I look at 1, I get a minus 5. And if I look at 2, I get a minus 2, right? These are not zeros. In fact, none of these possible zeros are actually zeros. So if what's in our box right here are all of the possible rational roots, but none of them actually are roots to this polynomial, then that means that this polynomial can't have a rational root. But isn't square root of 6 a root of this? If you plug in square root of 6 into here, you get square root 6 squared minus 6. Yeah, so square root of 6 is a root of this polynomial, but we just showed ourselves that this polynomial does not have any rational roots. Therefore, square root of 6 cannot be rational.